Now, better? So, okay. My name is Vandana and I work on the HBase project in Yahoo. I'm here to talk how HBase is being deployed in a multi-tenant environment at Yahoo. I do a brief overview of HBase and then hand it over to my colleague who will talk about the various features we introduced on HBase on top of the open source work. So, at a high level overview, HBase is an open source implementation of Bigtable. It's based on a paper that Google published, and it can be described as a database for contour Hadoop. It can be associated with a lot of attributes like distributed, scalable, consistent, random access, and key-value store. So let's quickly take a look at the HBase data model. At a high level, if you consider this table, it looks like a SQL table, but there's a kind of a different notion around it. So every table consists of particular pairs. So every row has a row key, and there's a notion of column family that's like a group of columns. So in HBase, if you have to address a value, then you have to give a row key, column family, and something called a column qualifier. In this example, column family is the info, and a column qualifier is the password. In addition, HBase supports versioning, so you can support various versions for the same data. So, if you consider the first row, Alice, presently it has a value for the password as strictly. You can always insert and gain another value called new password. So, it supports multiple versions. Although you can control how many versions you want to store. And so, essentially, each of the values are called cells in HBase. So, to address a cell, in short, you need to have a row key, a column family, a column qualifier, and a timestamp. If you don't specify a timestamp, by default you get the latest version. So let's take another example of how HBase operates in this distribution. Say you have a table which has user name as the key and user profile as the value. So this table, once it grows, it's always lexicographically ordered. So in HBase it's all ordered, and HBase shards it into something called regions. And each shard is actually contiguous keys. Now this table we want to split into three regions: R1, R2, and R2. And now HBase has a master and a bunch of region servers, and each region server holds a lot of regions. So in this example, the P1 R1, that's the region 1 of table 1, is gone to region server 1, and the remaining two regions have gone to region server 2. So it's not necessary that all the regions get distributed to all the region servers. The assignment is done in a random fashion. Now let's see how the read part goes. Say suppose you want to read it row in HBase. So there's a client who wants to read a particular person's row in HBase, say Sumi. Now what the HBase client does is, it goes to Zookeeper and finds the relation of the root region server. The root region server gives the information about where the meta region location is. So the root region and meta region serve as the catalog tables for HBase. Now the meta region has the information about where a given region is for a given table. So it actually contains the information about where T1's region is given for a given row, which is unique in our case. Now, once we have the region server location and the region location, the client actually goes and reads it at the key. So this is how this happens. And usually the client caches its location and reuses it. Once the client finds that the data is stale, it goes to the Zookeeper and gets the information again. Now, the write part is very similar, just that instead of reading, it doesn't do. And in case the region goes beyond a certain size, it splits. This is a very high-level component diagram of HBase. The statement of the HBase book. So, as I described earlier, there's a master, there's a Zookeeper, and a lot of region servers. So each region server sits on a log file. So the HCatalog is a redirected log. So whenever you try to write data into HBase, once first the log entry is written and then only actually the data is written into the table. This helps in recovering when reaching server crashes. And so all the region servers periodically report to the master, and the master just orchestrates the cluster. It's very lightly loaded. And you can see that there are a lot of stores in each of the regions. So each store represents a column family. So data is actually stored in a columnar fashion in HBase. And once whenever data is written into it, it goes to the mem store. So once data in mem store, and once the mem store reaches a certain size, it's actually flushed and created into immutable H files. So H files actually describe HDFS, and that's how it's replication and high availability. And some of the main high-level operations on HBase that we do are the get. So you can get a row, specifying a row key, and there's a get API, and you can specify a lot of other attributes. This is a very high-level slide. We can go good and scan and specify attributes to it. Then you can go check and delete, as in you can specify a value and say the value exists in this delete. This is a way to check and prove. If a value exists, then just put it, otherwise it won't. And then increment a value in a column, so you can use it as a column. There's certain things to know, they're not very HBase, and security guesses. So with this, I hand over to my colleague Francis, who will talk about how we are deploying HBase in a multi-tenant fashion.
Thanks, Vandana. So I'm Francis, I also work for the HBase team. So just to set the stage, we have been using HBase for quite some time now. So we've had a number of successful deployments, as Sumit said. So one of them is Core, which is our user personalization engine. And so whenever we hit our partner.com, it actually powers it. Another is what I call cache, which is the main cache. And at the time of deployment, it was the largest HBase cluster at over 900 nodes. So obviously, HBase is useful, and for these two projects, they mainly use HBase for off-stage processing. And the main motivation behind it was for mutable data and for random reads and writes. So let me walk through a number of use cases which sort of leverage these features. So one of them is sort of the metrics analytics use case, where you basically have a number of collectors, and then it collects data, and then just passes it through ingestion, and then writes it to HBase. And then you have web UI or something to actually query custom data at more or less low latency. So for example, OpenBSD and HCatalog database makes use of this sort of paradigm. Another is we almost a lot of data, so we have a number of data warehouses. So another way to use HBase is to actually have it store dimensions, become a dimension store essentially. And so basically you have your fact table in HDFS and your dimensions in HBase, and then you combine them using MapReduce table type. So for example, we have your clickstream as your fact table add campaigns with your dimension data, and then you can, for example, calculate the amount of money per month. Another interesting use case is sort of this incremental cost use case, and the general idea here, I think Andrew will be talking about more, is that basically you have two paths, a fast path and a slow path. So the fast path will essentially process events streaming, and then we'll do sort of quick, maybe rough calculations based on, for example, user profile, and then store that data in HBase as well as write it into a service store. While the slow path will basically bunch up these events into files stored in HDFS, and it's processed much slower, but probably will be able to do more complex calculations as well as read through a larger amount of the data set. The main takeaway here is that you have HBase with your shared context, essentially. So basically, both are reading and writing with the same HBase and sharing the same information. So if you look at the last few use cases I mentioned, you essentially have different access patterns, different workflows that HBase would have to support. And so let's look at Yahoo, which is also a hosted multi-tenant service. So one thing you have is security, which you always need for multi-tenancy. Another is queues to guarantee compute resources. And then finally you have HFS code that guarantees disk resources. So for HBase, you also have security. And then in order to guarantee resources, we pick a certain deployment and then added two new features in order to be able to guarantee resources. So first, let's just a quick overview of security. So HBase has similar security model as Hadoop in essence that it also uses kernels for authentication, and it also uses delegation tokens for dynamic running processes such as packages and or implements on the arm. So and then you have HBase has support for ACLs for authorization. And you can grant permissions on a user or a group. And these ACLs can be applied at the table, column family, or column level. One thing to note is that only the global admin can actually create the tables, which is sort of a bottleneck if you're hosting a multi-tenant service that ESD will essentially have to be going through a number of tickets to actually do these things. So as I mentioned, we sort of went with an isolated deployment. So the idea here is that you want to separate your, you don't want the compute process to actually contend for resources with the HBase process. So the problem here is that it might be contending for I/O if Apache has to spill, or for actually US cache, or contending for network or memory. So we essentially have two HDFS instances. One is for the HBase cluster, which is on the right, and then the other is the compute cluster, which is on the left. One small correction is that the compute cluster now runs around, but this is packages. You get the gist. So we've already isolated the compute resources from compute contention from the HBase storage contention. So now, one thing to keep in mind with HBase is that when you serve out tables, you have the region server, which serves out the regions. And these regions can actually come from different tables, which may be from different tenants or users. And so the problem here is that now your tables will be contended for resources. So, for example, someone might be taking your region's data from the link cache, or maybe you're contended for I/O again when you're writing. So what we did was we added we're contributing this feature in HBase where you can designate a subset of the region servers as a group, and you can assign members of the table to a region server, so that basically these subset of region servers will be specifically serving those tables. So therefore, we guarantee those resources, those region server resources to a tenant. So there's that level of isolation between tenants. So here are just examples of some of the APIs to give you an idea. So you can add a group, remove a group, move servers between groups, you can move tables between groups, and you can also create the table and at create time assign the table to a group, which is useful if you're pre-grouping your regions, your table. So here's a high-level component diagram of the region server group module. So all of this is designed in the HBase master, and the blue boxes are the ones to be implemented. So essentially what happens is that we've written this custom balancer. The balancer is what the master talks to when it's priced in a kind of region. It will say, these are regions, these are the servers, give me an assignment. So that information is passed to the group-based balancer, which is what we wrote. And then that information is further grouped into servers that are part of a group, the same group, servers and tables that are part of the same group. And that information is serially fed into the actual load balancer. So therefore, you're basically telling the load balancer, just balance this subset, give you the results. And then combine those results and then back to the master. So this is sort of how we guarantee that balancing. The other two components is the endpoint and the server. Those are used to support the APIs that we've added. So the HBase has this nice notion of co-processors, which allow you to sort of extend HBase to new features, and we leverage that here. So all this new information we've added is stored into just another HBase table. And we've also stored some information in Zookeeper, sort of as a bootstrap mechanism. So another thing we've added is the notion of namespaces. So the idea is similar to databases in MySQL. So basically we now have tables that are members of a namespace. And we've added this location of required tables to have basically a dot to designate the namespace and the table. And also we've added two reserved namespaces. One is the default, which is sort of allows to the draw package. This is just more for backward compatibility for tables which have no namespaces. And then we have the system table, which at a later point will have more things specific to it, but right now it guarantees that these tables are loaded before the user tables are, which is essential for features such as region server groups. And one thing to note, we've also added hierarchy to how tables are stored in HDFS. And this is useful if you actually want to apply HDFS progress on namespaces. So tying all of this together, you have security, you have groups, you have namespaces, but there's sort of no clear way of sort of grouping them together. So what we've done is we've made security aware of namespaces, groups aware of namespaces, and we've added focus into namespaces. So what happens here is that now you have the groups of tables, you have namespace ACL so that you can actually give project admins their own privilege to create and run the tables, thus removing that bottleneck with the HBase system admin. And now also you have a default region server group per namespace, and what that does for you is that whenever you create a table, it will always end up in that group. So you sort of created this workspace. This namespace as your workspace for the tenant. It's sort of the whole environment. On top of that, we've also added quotas. So the reason behind this is that even though we've given people their own set of region servers, there are still certain things that are shared across users. And one of those is the master, the meta table, Zookeeper. So we've added some quotas sort of regulate or limit the use of it. So as a starting point, we added limiting the number of tables and the number of regions. So here is a component diagram of the namespace component and the quota part of it. So we have extra namespace APIs in the master. You have this helper classes to actually store information in an HBase table, and in Zookeeper for orchestration. And then you have this controller which resides and runs in both the region servers and the master who guarantee these checks and actually police the quotas, enforce the quotas. So in conclusion, HBase, as I gave examples, enables new processing paradigms over just using HDFS. A namespace provides tenants with a project space by which they're more independent and more flexible in dealing with the resources. And so these features, region server groups, guarantees isolation, quota limits, the use of shared resources, and the namespace basically help project level isolation. So these are the references. So anyone who wants to know more about HBase, go to the HBase site. And then these are the unit numbers for the features build. Any questions?
For authentication, there will be any overhead and like any performance degradation when you add quota, is the same thing?
Yeah, I would say it's minimal. So we try to have all the information in memory, especially for quota as much as possible. And so there is no idle overhead of enforcement quota.
If I can just quick question. The namespaces are hierarchical, or can I have only one?
You can only have one. Sort of similar to RD and SS, they only have one. Yeah.
Thank you.
Questions for Francis on that? Very cool. Thank you, guys. Next up, we have two special guests who were two original faces, I would say, from the Hadoop project, Alan and Owen, and they will probably introduce themselves. But most importantly, they are from Yahoo, still semi-Yahoo.
All right, well, we get the slides up there. I'll just start talking a little bit. Apparently my computer doesn't like the projector there. So I'm Alan Gates. I'm one of the founders, co-founders of Hortonworks. As was alluded to, Owen and I both have been on Hadoop and related projects for a very long time. Owen, I think, since about day one. And me since day one plus a year or 18 months or something like that. So we're here to talk about this Stinger initiative. Oh, that's going better. Good. So what is Stinger? A lot of people ask me, when can I see the code for Stinger? Where can I download it? Stinger is not a new product.